So welcome back. Till tomorrow we have read up to this example where we were linking chances to probability. Next is outcome as event. Okay. So each outcome of an experiment or a collection of outcome makes an event. Experiment, just for example, we call tossing a coin as experiment and its outcome are head or tail. So these are events. Outcomes are basically events. Rolling a dice is an experiment and its outcome 1, 2, 3, 4, 5, 6, and all these are events or outcomes. Outcomes are basically events. For example, in experiment of tossing a coin, getting a head is an event and getting a tail is also an event. In case of throwing a die, outcomes, all these outcomes are events. Okay, so just we should learn the terminology. In getting a even number as an event, is getting an even number is a event? Yes, surely. When we roll a dice, the events of getting a even number are 2, 4, and 6. So these are also some events. Since an even number could be 2, 4, 6, getting even number is also an event. What will be probability of getting an even number? So what will be the probability? Total number of outcome is 3. Total number of outcome of getting even number is 3, and our total outcomes of when we throw a dice is 6. So 3 by 6 is 1 by 3 by 6 is basically 1 by 2. So the probability of getting even number is 1 by 2. Okay. Example 3. Example 3 says that there is a bag which has which has 4 red balls, 2 yellow balls. The balls are identical in all respects other than colors. So just if you touch the ball, if you experience the ball, they are identical in all respects in shape, size, and touch and feel. Just their color is different. One is having red color and other set of ball is having yellow color. So next, a ball is drawn from the bag without looking into the bag. So you just put your hand in the bag and you are unable to see the color of the ball and you just have to pick the ball. What is the probability of getting a red ball? So to what will the probability of getting a red ball? So probability of getting a red ball of total number of red balls are 4 and total number of balls are 4 plus 2, that is 6. So getting a red ball probability, its probability is 2 by 3. Okay, 2 by 3. Next, is the probability more or less than getting a yellow ball? Is the probability of getting red ball is more than uh, that of getting a yellow ball? Yes, clearly, because the number of red balls are more, so you have more probability of getting a red ball. So 2 by 3 is the probability of getting a red ball. But what is the probability of getting a yellow ball? That will be total number of yellow balls by total number of ball, that is 1 by 3. Clearly 2 by 3 is greater than 1 by 3. So probability of getting a red ball is twice that of getting a yellow ball. Therefore, the probability of getting a red ball is more than that of getting a yellow ball, and by how much more? That is twice. Try these. Suppose you spin a wheel. Okay, this is the 4.8. This is a wheel, and you try to spin this wheel. List the number of outcome of getting green sector and not getting a green sector on this wheel. Number of outcomes. So how many green sectors are there? So total number of outcomes are, if we just found the total number of outcomes irrespective of whether it is green or red, so 1, 2, 3, 4, 5, 6, 7, 8. Total outcomes are 8, and the outcomes and the outcome of getting green, for green, the number of greens we have to count: 1, 2, 3, 4, 5. So 5 greens are there. Now, what is the probability of getting a green sector? Simply it will be 5 greens out of total 8 outcomes. So it will be 5 by 8. What is the probability of not getting a green sector? So not getting a green sector is, in other words, it is getting a red sector. So 1, 2 and 3. So 3 by 8. 3 by 8. Another way of finding this not getting a green sector is simply 1, we should minus 1 minus probability of getting a green sector will be the probability of not getting the green sector, that is, it will be 3 by 8. So just for verification, these two values are equal, this and this is equal. So if we have probability of getting some event is x, then probability of not getting that event is 1 minus x. Chance and probability related to real life. We talked about the chance that it rain just on the day when we carry a raincoat. Okay, हम रेनकोट ले जा रहे हैं और उस दिन हम रेनकोट नहीं ले जा रहे हैं और उस दिन क्या प्रोबेबिलिटी है कि बारिश हो जाएगी. What could you say about the chance in terms of probability? In terms of probability, what can you say about that? Could it be 10 days during a rainy season? The probability that it is then 1 by 10. The probability that it does not rain is 9 by 10. Okay, simply if the probability of raining is 1 by 10, 1 by 10, then the probability of not raining is 9 by 10. Just the thing I have just explained here. Assuming raining or not raining on a day are equally likely. Use of probability is made in various cases. The use of probability is made in various cases in real life to find characteristics of large group by using a small part of group. Suppose we need to get some probability of someone winning. You might have seen this in election. There is term called as exit poll. What they do polling on, suppose there is your town is having a population of 5 lakh. So a small TV channel cannot survey 5 lakh people, so they will simply survey 10,000 people, and out of the 10,000 people they will get probability of BJP winning is 20%, Congress winning is 10%, some other party winning is 5%. So they will use the data of certain 10,000 I will say 10,000 population to exaggerate or to find the data for 5 lakh total population. For example, during election an exit poll is taken. This involves asking people how they have voted for, and when they come out of voting at the center, they are chosen offhand and distributed over the whole area. This gives an idea of chance of winning each candidate, and prediction is made based accordingly. Suppose your school total population or total students in your school is 1000. So then in your school is planning to have some event, for example cultural event. So they want to find how many students are going to participate in cultural event. So they cannot ask 1000 students. So they will uh, ask about 200 students, that uh, whether out of 200 students they will find that 50 50 students are 50 students are ready for some cultural activities. So out of 50, out of 200 they could find 50%, 50 students. So the probability of someone interested will be 50 by 200, 50 by 200, 50 by 200, that is in terms of probability we will find it will be 25%. So 25% person will be participating in the events, okay, in the cultural event. Meteorological department predicts weather by observing trend from data over many years in the past. So meteorological departments also predicts the event, the weather based on their data of many years. Okay. Now a very important thing, that is exercise 4.2. List out outcome you can see in these experiment. Okay. Just I will so this is list out outcome you can see in these experiments. You have to just list out the outcome. Spinning a wheel. So here the wheel is a spin. So number of outcomes, we have to just see the outcomes. So list the outcomes. You have to just list the outcome. So what will the outcomes of when you spin this wheel is? The outcome will be either A, B, C or D. Okay. In case of tossing two coins together, one coin and two coin, the outcomes will be, what will be the outcomes? So here head, here also head, here head and here tail. This coin is having tail and this coin is having tail, this coin is having tail and this coin is having head. So only these outcomes, these four outcomes will be there. Okay, when a die is thrown, list out the outcome of event, list out the outcomes of an event of getting a prime number. So list out the outcomes of an event of getting prime number. So prime number, so total number of total outcomes are 1, 2, 3, 4, 5 and 6. So out of these 6, the getting prime numbers are 1, 3, 2 only. Not a prime number, not a prime number, so 4. 4 outcomes are of not getting a prime number. Number greater than 5. So there is one outcome of getting a number greater than 5. Number not greater than 5. So not greater than 5, 1, 2, 3 and 4. So just 4 outcomes are and 5 also, including 5 also. So 5 out of 5 events are 5 outcomes are event of not getting number greater than 5. Find the probability of a pointer stopping on D in question 1a. So in question 1a, we have to find the probability of a pointer stopping on D. So how many sectors are for D? There is only one sector for D. And total how many sectors are there? Total how many outcomes can come in this case? So number of outcomes 1, 2, 3, 4, 5. So 1 by 5 is the probability of pointer stopping on D. Okay, next, the probability of getting an ace from a well shuffled card of 52 playing cards. Okay, so first you have to know how many aces are there in card? Cards are very favorable, I will say, topics in case of probabilities. So there is a, I think then the probability there is something, some favorite cards are very favorite, I will say, area in the chapter of probability. But personally, I have never played cards, and um, but still you have to know the cards, the division of card, the constitutes of card. Just for this example, I will say that there are four aces, total number of aces in a card of 52 packs. There are four aces and total number of cards are 52. So the probability of getting an ace will be 1 by 8. Actually, I will explain someday the constitutes of cards, because don't know why they are adding question of card in maths. Anyways, it's not very popular or standard game. Anyways, the probability of getting a red apple in this figure. Okay, if you are going to pick up the just by any random experiment, you are going to pick up a apple out of these apples given here. So what is the probability of getting a red apple? So just you have to count the number of red apples and keep it in denominators, and the total number of apple numerator and total number of apple in denominator. Okay, total number of apple in denominator. So total number of red apples are 1 2 3 4. 4 total number of red apples, and total number of apples are 3 3 and 1, that is 7. So getting probability of getting red apple is 4 by 7. Next example is number 1 to 10 are written on 10 separate slips. Okay, so there are slips having number 1 to 10. One number on one slip kept in a box and mixed well. The slip is chosen from the box without looking and into it. ना राजा मंत्री चोर सिपाही खेला होगा आपने, तो इसमें 1 2 3 4 लिखकर आइडेंटिकल स्लीप्स में उसको फोल्ड करके एक डब्बे में रख दिया. नाउ what is the probability of getting a number 6? So number 6, there is only one event of getting number 6, that is that parchi only in which 6 is written, and total number of events are 10. So probability of getting a number 6 is 1 by 10. Probability of getting a number that is less than 6, the total number of events that are less than numbers having less than 6 are 1 2 3 and 4 and 5. And total 5 such events are there. So the probability of getting such event is 5 by 10. 5 by 10, that is 1 by 2. What is getting probability of getting a number greater than 6? So number greater than 6 are 7, 8, 9 and 10. So these are 4 events. So 4 out of 10 is 2 by 5. 2 by 5. Getting a one digit number. So out of these 10 outcomes, the 9 numbers are one digit. So the probability of getting a one digit number is 9 by 10. If you have a spinning wheel with 3 green sectors, 1 blue sectors and 1 red sector, what is the probability of getting a green sector? So if you have a spin, if you have a round spin having 3 green sectors, so total number of sectors are 3 plus 1 plus 1, that are 5 sectors. So we will draw a spin, 4 sectors and 1 more sectors. So out of these, 3 are green, G, G, G. Okay, green, and 1 is blue and one is blue and one is red. Okay, one is blue and one is red. So what is the probability of getting a non-blue sector? First, what is the probability of getting a green sector? So total number of green events are 3 and total number of events are 5. So 3 by 5. What is the probability of not of getting a non-blue sector? So a non-blue sectors, uh, 1, 2, 3 and 4. 4 are non-blue sectors out of 5. So 4 by 5 is the probability of getting non-blue sectors. So what will be the probability of getting a blue sectors? So it will be 1 minus probability of getting a non-blue sectors. That will be 1 minus 4 by 5, that will be 1 by 5. So just for recap what we have discussed so far. In order to draw meaningful inference from any data, we need to organize data systematically. Okay, so that is our chapter on data handling. Data can also be presented using circle graph or pie chart. Okay, so we just learned about a circle chart or pie chart where we were drawing sectors with angle corresponding to the population or the ratio of the data. A circle graph shows relationship between goal and its part. There are certain experiments whose outcome have equal chance of occurring, just like when we throw a dice, every outcome has equal chance of occurring. A random experiment is one whose outcome cannot be predicted exactly in advance. So random experiment like tossing a coin or throwing a dice, these are random experiment because the outcome cannot be predicted in advance. Outcome or experiment are equally likely if they have same chance of occurring. Okay, so these type of experiment are equally likely, every outcome have same chance of occurring. Probability of an event is number of outcome that makes an event, so number of outcome that makes that event, and total number of items of that experiment. One or more outcome of experiments makes out an event. So every outcome of an experiments are events. Chances and probability are related to real life. Okay, you just